call a loop. So look at this scenario. You have a list of values, okay? And if you wanted to add 10 to every value present in the list, how will you do it manually? So let's say sample list of 0 plus 10, 20. Sample list of 1 plus 10, you'll get 30. Sample list of 2 plus 10, you get 21. Yes, this is how you'll do it manually. Yeah, so that is the for loop. That is the for loop that we'll be doing. So instead
Okay.
of manually doing this for every element, you can actually iterate through the elements programmatically. Okay. So how do we do this programmatically? Let's say you have a list and you define a for loop. So for is the keyword. So for my num in sample list. So my number in sample list. If I'm just checking, if my number is equal to 10, I'll just print, oh, it is 10. Otherwise, print the number is. Okay, so maybe before complicating this, look at the simple one. Yeah, before going here, let's look at a simple list loop. See what I'm doing here. So this is a simple loop for my num in sample list. Print my num plus 10. So what I'm doing, my num is taking the value 10. I'm adding 10, 20. My num 20, print in here. So if I just print my num, see 10, 20, 11, 5, 40, 100. So it is iterating through every value and it is taking that value. Now with that value, I can perform calculations, right? I can add something, I can delete something, I can divide, multiply, whatever I want to do with this number, I can do. The syntax is for an iterator. So instead of my num, can I use I? Yes. Can I use A? Yes. Can I use ABC? Yes. Can I use KBC? Yes. Anything. So any variable that is a valid Python variable, you can use as an iterator. Mostly you will see this as I. Okay. Is the nested for loop and we'll study after this.
Okay.
So what's happening here? Is this clear to everyone? What's happened here? I defined a temporary variable I. So for I in sample list, print I means it will take, I will take one value each one by one. So I will be first 10, then it will be 20, then it will be 11, 5, so on and so forth. Is this loop clear to everyone? What's happening in this loop? Yes. And then you can understand that I can just, add values or divide values, do all sorts of operations, correct? So now I have I value 10. So 10 plus 10 divided by 2. Sorry, it's some BODMAS. So it will be like 10 division by 2, then addition will happen. So yeah. So you can add values instead of adding manually. You can use this loop and do this operation on all the values. So here right now you have 6 numbers. Even if you have 6 million numbers, the same syntax will work. Okay, but you cannot do this manually for 6 million numbers. So that is what we use for looping. It's called for looping. Okay. Now look at this one now. What I'm doing in my loop, I'm doing a lot more things. I am looping through the values using a variable called my number. Instead of I'm using my number and I'm saying my number in sample list. If my number is equal to 10, then print, oh, it is 10. Otherwise, print that it is my number. Okay, and then print my number and my number plus 10. Then also print my number multiplication by 10. I'm just doing multiple type of operations to show you that within a for loop, you can perform all of these calculations. How many number of times? the number of the number of times equal to the number of values. Okay. So if there were 10 values, it will perform the whole set of operations 10 times in the for loop. Now in the end, what will be the value of mynum? So mynum is taking values like 10, 20, 11, 5, 40, 100. So in the end, what should be the value of mynum? 100. Yeah, the last value will be with mynum, the iterator value. Now over here, instead of passing a custom list of values, you can also create a range of values using the range function. So it says, tell me what is the minimum, tell me what is the maximum, and how do I step in between. So minimum to maximum with a step of 2. So 20, 22, 24, 26, 28. 30 will not be included because it's the range. Whenever you provide a range in Python, the last index gets excluded. If I say hop by 1, so it'll hop by 1. Okay, if I say hop by 1.5, sorry, it will not work. My bad. If I say hop by 3, 20, 23, 26, 29, like this. It will hop by those integers. Okay, so range asks you three inputs: starting point, ending point, and what are the values for hopping. Now, look at this one. What we are doing, we are running a for loop and we are evaluating conditions within it. So my tuple, I'm iterating through a tuple. So my tuple contains character, 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 list, and character. Okay, these are the different type of values. So I'm saying for my value in sample tuple, I'm iterating, my value will become A, then my value will become B, then it will be C, D, and then it will become a list. So I'm saying print my value, print the length of my value. In the first iteration, what will be the length of A? 1. And what is the type of my value? Type of string. String. Okay. Then it will go from A, B, C, D. And then when it reaches this point, what will happen to the length of my value? 3, because there are 3 elements in the list. So it will output 3. And what is the class of this object? It is a list. So I am saying if the type of my value is a list, I'm checking the data type of the values. If the data type is list, then for every value in I present in this my value, print I. So if it is a list, I am printing it. Okay. If it is a character, I am not printing it. Okay. So this section will execute only when the type of my value will be list. So in the first iteration, when my value is A, which is a string, this section will not execute because this will evaluate to false. Okay, A will not be a list. Okay, type of B will not be a list, so on and so forth. Look at this. So far, what we have is a one iterator. Like my value is one iterator, and you have a list of values. So my value will take this, 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 this. What about if I have multiple lists or multiple tuples? Can I iterate through them parallelly? Yes. So this is one list, another list, and there is a tuple. Okay. Different kind of values, like 4 values, 3 values. If I parallelly iterate, let's say 10 with 1 with A, or 1, 10 A, here I'm showing like 1, then 10, then A. So parallelly, if I'm iterating, I'll be able to iterate 3 till 3 point, because the smallest variable contains 3 points. So if I'm doing a parallel iteration, then I'm doing this against this, against this, then this against this middle one, then this one, then the third one, third value with third value with the third value. Fourth value, oh, there is no fourth value, so it will stop. So whatever is the smallest list, that will dictate the number of parallel iterations that you can do. Okay, so this is known as zipped iteration or parallel iteration. So I am defining 3 iterators here. Numeric iterator, I've used I as the iterator for the list, and then character iterator for sample tuple. Okay, so the order in which you define it here, they will be assigned the objects in the same order. So you have to use the zip parameter or zip function To define that, you are creating a zipped iteration. So numeric iterator will be iterating through the values of another list. I will be iterating through the values of sample list, and character iterator will be using sample tuple. Okay, so if you jumble this up, corresponding objects will be assigned to it. Okay, so you need to make sure that the order is correct in the same order that you want to iterate. Okay, so numeric iterator, another list contains 1 to 3, so it will go 1 first. Then I'm just giving a space combining with I. So what first value I will take? So I is iterating sample list. Sample list contains 10. So 10 will be taken up. Then giving a hyphen here, then character iterator. So character iterator is sample tuple. So A. So 110A is the first combination. Similarly, 220B is the second combination. 330C is the third combination. And then there is no more combinations because it exhausted. If I add more here, then it will go till 4. Why not 5? Because the remaining objects contain only 4 values. Okay. So this is known as parallel iteration. It is one of the hallmarks of Python. You won't find this in other languages much. Okay. Zipped iteration. Zip is the keyword. Making sense? As compared to parallel iteration, the nested iteration is used more because it creates all the combinations that are possible. So over here, it'll at max can produce 4 combinations, right? If you have 4 values. But in this scenario, if you use nested iterator, then what will happen? So for loop inside a for loop inside a for loop. This is called nesting. So then it will go like 10 with A with 1. Okay. 10 with A with 2, 10 with A with 3, like this. 10A1, 10A2, 10A3. Okay. Then 20 will start. 20A, 20, 20, uh, 20A1, 20A2, 20A3, so on and so forth. Then 20B1, 20B2, 20B3, so on and so forth. So first 10 and A combinations will finish, 10 B combinations will finish, 10 C, 10 D. Then all these combinations are finished. Then 20 will start. So it is like nesting all the combinations, like finding out all the possible permutation and combination of these values sequentially one by one. Okay. So what we are doing, I'm saying the numeric iterator is in sample list, character iterator is in sample tuple. So inside this for loop, running another for loop. So for every value of numeric iterator, let's say 10, 20, 30, 40, for every value, do another for loop and go through every value of character iterator. So for 10, it will go to 10A, 10B, 10C, 10D. Now for every value of 10A, 10B, and 10C, go and do another looping for I in another list. So 10A1, 10A2, 10A3, like this. So it'll iterate through all those combinations, and what I'm doing with those combinations, I'm just printing the combination. So print the numeric iterator, print the character iterator, print I, and also print I plus numeric iterator. Okay, so I'm just adding I plus the value. So this value plus this value. I'm adding 10 plus 1, 11, 10 plus 2, 12. Okay, so I'm just creating a manipulation also. Now here, once again, I'm printing the same thing, but I'm trying to show it in a animated manner to help you understand that yes, it is happening for a for loop. So let me change the convention. Iterator 1 is going through the sample tuple. Iterator 2 is going through the sample list. So iterator 1 against iterator 2. Okay. I'm changing the convention for you, for your understanding. Okay. So what I'm doing, I'm printing it and then I'm pausing for a second. So time module, time library allows me to put a 1 second sleep in the for loop. So print this, come here, sleep for 1 second, wait for 1 second, then go back in your for loop again. So you see, you are able to now visualize that the for loop is happening one after the other. Let me also give it in the same order. So A10, A20, B10, B20, like this it is happening. So the sleep parameter is for second. If you increase the seconds, it will sleep for more time, 2 seconds. Okay. Now, while loop. Another type of loop. So for loop is very popular. Another type of loop that is also popular is called while loop. So for loop and while loop, how they are different. When you run a for loop, you run it for a given set of combinations and there is no stopping. Once you started a for loop, it will run for all the combinations and then it will stop. Okay. In a while loop setting, you can actually just keep checking the condition, like whether my condition is true or not. And at a particular point, if your condition is not true, then you can simply stop the loop. Okay, so while loop checks the condition every time before running the operations. So let's, for example, over here, I'm creating a counter. Counter is equal to 1. I am saying while the counter is less than 10, print before update what was the counter value, then wait for 1 second, and then update the counter. Counter plus equal to 2. This is a shortcut to write down the same statement like this. Counter is equal to counter plus 2. So I'm increasing the counter with 2. Okay. So instead of writing this, I can use a shortcut. The shortcut is plus equal to. Plus equal to means counter is equal to counter plus 2. Okay. Now, after after the update, I'm just printing it. So before update, it was 1, then I updated 2, then it was 3. Then it went here. Then once again, it it printed that it was 3 before the update. And then I waited for a second and then added 2 to it. Then it became 5. I printed it. Then I went again. 5 less than 10. Yes. Once again, do the same thing. 7. Then once again, do the 9. Then in the loop, when it became 9, then I added 2 to it. Then it printed 11 and then it went here. At this point, the loop will stop. Why? Because the condition became false. So till the condition was true, till the counter was less than 10, it kept doing the things. And the moment the condition became false, it stopped. While loop essentially checks the condition, and then based on the condition, it either decides to run the statements or chooses to not run the statements. Okay. This type of loop becomes very helpful when, let's say I wanted to check whether to run my data warehousing script or not based on whether the file is present in a particular location. So you can, determine that, okay, you can give a timing, let's say after every 30 minutes, it should check whether the file is present or not. And then based on that, it will decide whether to run it or not. So every time, if it is present, then it will continue executing. If it is not present, if the value is not present, if the location is empty, then it will stop executing.